Welcome to Critique. Welcome to Critique of the Peer Review Science Channel. Donate to our channel on PayPal, pernaturallinguistics@gmail.com. Peace and blessings, everybody. This is Not Your Neb. I just want to say today, I was awarded my history degree. I was awarded a AA in history. My Associates of Arts in History. So I'm going for the BA or the BS, Bachelor of Science in History, next. And then, of course, I will be going for my Master's in Linguistics, which is my ultimate goal. So it's been a struggle. It's been hard, but we're getting it done. So today I will be bringing up this peer review data, if today is possible. I know that it's possible that we may have to do a series of this. So here, this is a peer review documentation, timely, and it speaks about mathematics in Central Africa before colonization. So before we get to this peer review data, I would like to get to another data first, using historical methodology approaches, which first, before we even get into mathematics, before we get into algebra, before we get into different forms of arithmetic and base 10 number systems, we first have to know that where's the chronology? When did math begin? So here is something from Jazeera. Right? So here's something from Jazeera, or Alazjeezra, or how you pronounce this? Let's see. Jazeera, right? That is like a Arab news channel. And this is what they stated on that channel. They claimed that this Muhammad Al-Khwarizmi is the father of algebra. And I will quote them directly. In the quote, it says, Muhammad ibn Musa al-Khwarizmi was a 9th century Muslim mathematician and astronomer. He is known as the father of algebra, a word derived from the title of his book, Kitab al-Algebra. His pioneering work offered practical answers for land distribution, rules on inheritance, and distributing salaries. If you look at this show that featured on the Al-Jazeera site here, which I sourced, and if you go there, it mentions the benefits of mathematics. Then it goes into the physicists there. It goes into that there's other mathematics, but he doesn't shed light on other mathematics or its history. So I think that's problematic. Muhammad Al-Khwarizmi is not the father of algebra at all. That's historically inaccurate. So we're going to go into early mathematics, Egypt and Mesopotamia. This source is by University of North Carolina, Wilmington. Let me get the exact name of this college. It's a .edu from a college. Okay, yeah, so it's UNCW, University of North Carolina, Wilmington. And this lecture is very important to know the history. And this lecture was created for this university in the fall of 2023. So it begins, shows the map of ancient civilizations of the old world, where we would have instances of dates here, ancient civilizations of the old world. And for some reason, it only starts from 3,500 to 1,000 BCE. Should be further in time, but still. All right. So this is the history of math. Early civilizations. And these are civilizations who chronologically had various types of mathematics. But we must go to the father of mathematics, which is really in ancient Africa, which is 20,000 years ago here. But really, it goes back 44,000 years ago. Arithmetic. Algebra, I don't know why they have Egypt separate from ancient Africa. All right. Egypt should be part of Africa. It is in Africa. Egypt is not even an indigenous name. It is derived from a temple, but it is from Greek, right? From the Greek. So this name, the populations never called themselves Egyptians. You won't find it in no primary materials that indigenous Africans of the Nile Valley called themselves Egyptians. And for some reason, he got Egypt separated from Africa. So this is, as a historian, this will be problematic for me. We must include Egypt as part of Africa. And we must add and tack on these years as well, because algebra began in Africa. Algebra and also other mathematics begin to develop separately in various cultures. A lot of pseudosciences, especially in various communities, speak about how this culture stole it from this culture and this culture stole it from this culture with no set evidence. But sometimes, right, that these cultures are not stealing, these cultures are developing math separately. So in Mesopotamia, they begin to develop a mathematical system around 3100 to 539 BCE. You have the Indus developing mathematics from 33 to 1700 BCE. And you have Greek, who is also developing mathematics in various types. And the Chinese, finally, in 1766 BCE to 220 CE. And you have Indian mathematics, Islamic mathematics. So all of these cultures, before we even get into Islamic types of mathematics, which the name algebra is derived from, the Kitab Algebra, right? That is way later. So according to universities of higher learning that teaches mathematics, mathematicians, professors of mathematics, there is no possible way that that person is the father of algebra. I'm sorry. Historically, it is not accurate. I'm not knocking the news channel. I just, to ignore the great African past and achievements of the oldest form of mathematics, and to just say that someone that comes after Indian mathematics, that comes after Chinese mathematics, and comes after Greek mathematics, that Islamic mathematics, the guy who invented the name of, or who we take the name of Algebra from, is the father of mathematics, is historically problematic. All right. So as we continue down, we have Mayan mathematics developed 250 to 900. Aztec Empire developed mathematics, and the Inca civilization developed mathematics. So here we get into ancient African mathematics, and we kind of have two very old artifacts. Right, artifacts. One artifact was in South Africa, which is called the Libombo bone, which is a baboon's fibula, and that existed from 43 to 44,000 years old. And this is the oldest known mathematical artifact known to man. It has 29 notches on a baboon's fibula found in Border Cave, Lubombo Mountains, Swaziland. This is South Africa. And as you see on the right, you see these notches indicating some type of numeric system. And the Ishago bone is also an example of arithmetic developments of African mathematics, and that is also developed 22,000 BC, and this is found in the Democratic Republic of Congo. Even though these names are mainly colonial, and that's what I go by until these places, of course, update and change their names to indigenous names. But it says Ishango bone, 20,000 BCE, also a baboon bone, Ishango, and it's found in its title after the place where it was found, and this is numerical patterns with differing interpretations. So we find differing interpretations there. Again, we are still in Africa, all right? Historically, as a historian, I see in the media is very problematic. They're not saying Egypt as is separate and it's not part of Africa. It's still this Egypt and then Africa. No, Egypt is part of Africa. Okay, it's part of it. It's in Africa. It's African. It is an African civilization. So we have, even in the early dynastic period, we will have mathematic writing. We will have in the Old Kingdom, we will have mathematic writing. In all of these periods, we will have mathematical writing. Now, when we get to Middle Kingdom, that's when we see the developments of more complex mathematics like algebra. And in the Middle Kingdom, from 2055 to 1650 BCE, we can observe, as historians, primary materials showing that mathematics is developed in Africa. And you see Reisner papyri, Moscow papyrus. Second intermediate period, which follows the Middle Kingdom from 1650 to 1550 BCE, and we have the Rhine papyrus, right, which has algebraic expressions, algebraic equations in it. So it says New Kingdom, also mathematics. So all throughout Africa, this is Africa. Ancient Egypt is not separate than Africa, but this is all falls in the line of ancient African mathematics. All right. Mathematics was developed in Africa. So as we see primary materials, even though this is just an introduction, I should label this part 1 because I don't think I'm going to be here too long. But I just want to skim through the chronology before we even get into the peer-reviewed documentation. So this papyri, different papyri, different dates. You have the Rhine, Moscow, Rising. And you see over here it's written in hieratic on your right. And then it's transcribed in regular or formal Medu-Neter, the basic glyph form, and you will have the hieratic here. And you will see that these are indicative of what they call mathematics. And you see that these are numbers in Medu-Neter, those who know about mathematics, Medu-Neter, or what they call ancient Egyptian. And I say they call because, of course, the indigenous populations didn't call themselves Egyptian. But historically, as we see on this primary materials, this actual document of hieratic writing from the indigenous populations themselves, we see they are using some type of stroke and some type of bone for numbers. That stick and bone were used for numbers and calculations in sub-Saharan Africa. And it's also peer-reviewed documentation that suggests math was actually brought into the Nile Valley from some sub-Saharan Africa. So this is why we find a connection with these sticks. You see that this represents 9, all right? As you see past the determinative, those who are not familiar with Medu-Neter, you normally have like this word. Let's see a word. Let's look at this. This is capita, K, F, M, and you see these bent items here. Let's make this bigger. This might be a little too small. You see these bent items that look like horseshoes. And then you see strokes. This is a bone. These are bones. And these are sticks. These bones and sticks were normal artifacts or normal devices that Africans from Central Africa and Sub-Saharan Africa were using way before the development of math even began in ancient Kemet, or land of the Blacks. All right. So we see other in southern Egypt, which is interesting. This is the southern part of Kemet. Is not one map is not stagnant in one area. You have different various forms of mathematics. Then you have in southern Egypt by Reisner 4 scrolls, and they were mostly accounts. You have Egyptian arithmetic, which dealt with base 10, counting 1 through 10, hieroglyphic and hieratic numerals, all right, integers, fractions, surveying building areas and volumes. I mean, you had a deep base of mathematics, and we can tell they had a deep base of mathematics, the way monuments are constructed, the accuracy, etc. So this gets into basically the Rhine papyrus and what it's good for and what type of mathematics it has. So it will have what they call geometry in this specific primary material from ancient Kemet, land of the Blacks. or what they call ancient Egypt today. Then you will have measures, grain, they're doing measurements, and they're doing areas of circles, right? And they also numbered the problems, and this is problem 48. They were doing Pythagorean triples, where they're Pythagorean triples, A, B, and C, and you see A exponent 2 plus B exponent 2 equals C exponent 2 there. And you have examples 3, 4, 5, 5, 12, 13 used to measure parameters or perimeters. Knotted ropes, loop with 12 knots. Now, this is very important. Mathematics, writing in Africa is not just writing on papyri or writing on paper or writing on stone, carvings. We also use knotted ropes called semiotic writing, which is not spoken about. And also other units was used for counting. For example, like fingers, the palm, and the cubic, which equals 7 palm. So here's Egyptian arithmetic, which deals with multiplication. In Africa, we dealt with multiplication. You had counting and unit fractions. Okay, so this is what I mean by the glyphs that we went over. You have the stick, the heel bone, the coiled rope, the lotus flower, pointing finger, tadpole, and astonished man, all representing counting and unit fraction. All right. So they saw some hieroglyphics for some fractions. So these will represent fractions. You see the R or mouth glyph, and you see how you have it over 2 sticks, the mouth glyph over 4 sticks, mouth glyph over 5 sticks. So this would how a fraction would look in Nile Valley, Africa. All right. So our good elder Chocho came in. He's a mathematician. He has a BA in applied mathematics. But we're going to carry on. All right. Oh, sorry. So here's the Rhine papyrus. This is problem 50. And as you see, we get into the transliterations. For those who are not, very good at Medinetra, this will be easy. It gives out the transliteration right here in problem 50. And it says, it gives us that it's doing multiplication. We see fractions. We know the remainder is, they're doing remainders. 8 times 8 becomes, right, 64. So this is excellent. You have Moscow papyrus. Is another papyrus that have mathematics in it. And it has 25 problems of mathematical problems. So they were doing quite excellent around 1850 BCE. And it shows the frustum of a pyramid. So this is C problem 14. Man, they are doing very well with mathematics. I already know Elder Chocho, our mathematician here, he's going to tell me to go back, I already know he went all the smoke with this, right? So then it gets into, of course, the fall of what happened with Egyptian. It gets into Babylonian and Sumerian mathematics. But like I stated, the chronology of mathematics began in Kemet. And we're going to really get into the separation of the different subjects of mathematics as we go on, etc. So these are primary materials: Egyptian arithmetic. We have the papyri scrolls, which is Rhine papyrus 1650 BCE, which deals with algebra expressions, and some of the Rhine papyrus, some of the Moscow papyrus deals with it. So that's go to this. The whole nutshell is that I just wanted y'all to know that according to that news channel, I'm not sure how he skipped all of these civilizations historically and said that the guy was the father of algebra. I doubt that. And also, I don't understand why Egypt, if these are mathematicians, so they should be able to problem solve with no problem. Egypt should not be separated from Africa. Egypt should be inside of Africa. It should not even be Egypt. It's not its own continent, right? It's not its own civilization. This is an African civilization that belongs, an early African civilization that belongs in the ancient African context. All right. So this is historical perspective with chronology. In respect to chronology and how chronology is important in dealing with where mathematics began. All right. Give me a sec. I'm going to show y'all some other mathematics, especially algebra. All right. No, sorry, y'all. So we're going to go to the University of Buffalo. This is the University of Buffalo. I have everything sourced in the description. So it breaks down the different types of mathematics. I showed you the different primary materials dealing with Nile Valley Africa. So the evidence for algebra being much earlier than the herb that was suggested on that Pacific News Channel is here. So it states, in our discussion on the Rhine, we discovered some algebra implicitly necessary for the Egyptians to do elementary computations. In our discussions of multiplication and division, we discussed how the Egyptians knew the unique decomposition of each integer as sums of powers of 2. Here we continue our discussions and hope to convince the reader of the Egyptian knowledge of perfect numbers and of arithmetic and geometric series. So as we see here on simple algebra, according to this .edu, which is a considerable good source, even when writing papers, etc. And also we do ourselves have peer review data that can back this. So we go to problem 72 in the Rhine papyrus. 100 loaves of Pisu 10 are to be exchanged for a certain number of loaves of Pisu 45. What is the number? So what are they? They are like they solving for X. In this simple algebra. All right. Just the translation. The Pisu number of a bread determined its strength in inverse order. In particular, Pisu 10 is stronger, better than Pisu 45, the number determining some kind of percent of something undesired. Thus, the problem reads in our modern sense as, what is 45 over 10, 100? Obviously, it's 450. Here's the Egyptian solution. So it's giving you simple algebra. First, find the answers of 45 over 10. You get 35. Divide 35 by 10, you get 3 plus 1 over 2, 1 half. Now multiply 3 plus 1 half. You get 350. Add 100 to 350, you get 450. The above may seem odd, but it is algebraically correct. Suppose we have X loaves of P soup and Y loaves of X loaves of P soup P is to be exchanged for P soup Q. So these Africans of the Nile Valley are doing algebra and they are writing the number out. The Arab, who is considered the father of algebra, wrote no numbers out. He's told stories in which they are computing to algebraic problems. In here in Africa, we find primary materials that shows the actual numbers. And that's where historically I look at, right? These are more simple equations, which is good. This is problem 24, the Rhine papyrus. A quantity, any plus 1/7 of it becomes 19. What is the quantity? All right. So they are trying to solve simple equations. Okay. More problems. That was problem 24. You got problem 28. This is also the Rhine papyrus. A quantity together with its 2/3 has 1/3 is sum taken away to yield 10. What is the quantity? All right. And as we go here, we get into dates, Moscow papyrus. Man, this is excellent. So those who are interested in this, to look at, various degrees of equations, simple equations, geometric series of simultaneous equations determining pi, geometric series in simple algebra, the inventory problem, a geometric series. So they are getting into this, man. This is excellent. Okay. So as we continue, we have more problem 28, problem 33. We have simultaneous equations, etc. We have arithmetic and geometric series. Traditionally, arithmetic and geometric series are attributed to the Greek Pythagoras. However, the traditionalists have erred. So this is a college, a .edu, saying the traditionalist has erred. For nearly 1,500 years earlier, we have arithmetic and geometric series in Nile Valley, Africa. All right. This is very good. For this is Gibbs excellent. It synthesizes primary materials quite excellent. And it breaks it down from simple algebra for all you mathematicians, for simple algebra to simple equations, simultaneous equations, arithmetic, and geometric series. This was done in primary materials. We're not just saying that that algebra is started from here, or algebra started from here, or he's the father of algebra. No, we are actually looking into historical methodology approaches. We are looking into components of historical methodology by evaluating what? Primary resources. Primary resources. Right. So this will be enough for today. Part 2, I will get more in depth with other papers and things of that nature. So just consider this as part 1. Just knowing that the historical perspective of math begins in Africa. All .edus, I mean, all universities, peer review data that's timely says the same exact thing. All right. So let's touch on this peer review data right quickly. So this peer review data is awesome for, we're going to get more into it on part 2, but this is sources for ethnomathematics. They give sources for it. Creating counting in Africa, how counting was proposed to be created. Number basis. Right. Talk about the simplest systems. Creativity in counting. Words for larger numbers. Counting gestures. We use signs and the hands for also numbers. Base 12. And these are different manifestations of hands symbols in Africa, and how we are computing math by demonstrating it on our fingers. This is also excellent. This is sign 6 for in Rwanda left and gestures for 4. All right. We just taking a brief review of this paper. Current linguistic studies. So these are some linguistic studies that deal with a mathematical nature, which historical linguistics has nothing to do with mathematics. But just in historical linguistics, we don't compare languages by calculating mathematics involved in it. We are using a different kind or different type of method. But there are different types of linguistics that also use approaches of math, like statistical linguistics or glottal chronology, which is a form of linguistics where we're dating languages. There are other types of linguistics that that work alongside certain forms of mathematics. You have graphs, mathematics, and Africa. All right. Geometric patterns, further geometric studies. Lines in the sand, dawn of number notation. So we started to write lines in the sand for number notation, and you see a chart here, which is known by differing Bantu people, so-called Bantu people. I don't know why they call Bantu people. Strange, right? And these are the knots in which I had interest in as a linguist, because we are always said that Africans had no writing from a certain point in sub-Saharan Africa. That's false. We had semiotic writing. This is also a legitimate writing system. Knotty counting, using those knots to count sticky numbers. And this is a 30,000-year-old carved bone in Europe. And this is the old carved bone from South Africa, which is older. All right. So here's a bone again, which I already showed before, that is a drawing of primary materials from South Africa, the Lubombo bone, which is 7.7 centimeters long. Bone appeared to be 35,000 years old and showed 29 clearly delimited carvings. So this is also counting sticks. And this is why I say when you get into Medu Neter and ancient Kemet, their hieroglyphs of their numbers are actually sticks. And then you have hill bones that curve into a U. Mental arithmetic. And I find it intriguing that now I'm actually suggesting this to teach reasoning without writing. So they give some reasoning here. Mental arithmetic, being able to count in our brains. So I would like to start something else. Mental algebra, doing algebra in our own heads. And it's possible, like the mathematician here who suggested to me that mathematics is a language. It is a written type of language, right? And in being that, if we can store language in our brain, then we can store mathematics because it's also seen as a language. Simple Makala games. So these are games in Africa we used to show that we put mathematics in our gaming systems. Research mathematics about African games. So studying African games, you'll get to study especially games from pre-colonial or natural games that your people may have access to. And it's a certain games that deploy mathematics. Complex reasoning without writing. You have your Yoruba calculations. And they get into these cowrie shells, which, wow, I mean, you know, there's a lot of Yoruba number names. And I think they have a base 20. Yeah. Yoruba number names refer to a base 20 and often use subtraction. Okay. A multiplication method based on doubling and halving, which is Egyptian arithmetic, is well known because of two papyri and secondary Greek and Roman sources. I mean, look at this. Higher algebra. All right. This is also interested in higher algebra. And knowing this, in small isolated communities, strict rules were sometimes formulated to avoid marriages between close relatives. People belong to clans. This word is not correctly used here, but other alternatives are even more confusion. With, for example, the rule that only people from the same clan are allowed to marry each other, and that their sons will belong to another clan, and their daughters still to another clan, and this following giving prescriptions. Mathematician lists the numbers of the clans in rows or columns called matrices. Let me pronounce this word correctly. Matrices. Let's see. Yeah, matrices. To summarize the situation where parents belong to clan 1 or 2 or 3, their sons to clan 2 or 3 or 1, and their daughters to clan 3 or 1 or 2. So they broke it down from parents, sons, daughters. Here we will leave these notational questions for what they are, but we can nevertheless provide a nice short example of a mathematical kinship theorem. Theorem in a society described above, a man is allowed to marry the daughter or the brother of his mother. All right. First, we know the man is always the grandson of his grandparents. If the grandparents belong to clan 1, their daughter, the mother of the man, will belong to clan 3. And so he will be in clan 1. Next, the brother of the mother of the man is the son of the grandparents and thus belongs to 2. While the daughter of the latter again is in 1. 1 proceeds in the same way if the grandparents belong to clan 2 or 3. The man and the daughter of the brother of his mother always belong to the same clan and thus are authorized to marry in that society. A reader recalling a few facts from theory of matrices may remember their multiplication. In this mathematical terminology, the proof of the above theorem states that, and it gives the theorem here, mathematicians draw the same conclusion from this as in above proof in words, quod erat demonstratum. A simple example of kinship ties in traditional representation from the Melicula in Oceania, only the letters are Western additions. So I'm not going to read all of this. So it gets into some complex mathematics, complex higher algebra. Then it speaks about proto-mathematics, etc., etc. So I would like to let the mathematician we have here in applied math, let him speak, see what he likes to say about this. I'll give him 10 minutes to summarize, and then Kadika is offline. All right.
Deep. How's it, Nap?
Peace.
Peace, my brother. This is deep, but I'm glad you gave it a very good historical perspective to see where things come from. But it's deep. When you talk about numbers, I mean, base, which is number systems, basically.
Right.
The last point that you touched on, actually, matrices, it's actually a concept that is used to solve what high school learners will call it, in simplistic terms, simultaneous. It starts off with simultaneous equations, right? But if you've got more than one equation, more than two equations, you've got systems of equations.
Mm.
Matrix algebra becomes one of you can perform certain operations like row echelon. It's called row echelon one. I'm just speaking bombastic words here. It's once you have matrices, matrix algebra, you are speaking high mathematics actually, because you're solving many equations at the same time. It's just a methodology of solving many equations at the same time. But at the same time, it speaks about vectors. You see, you're speaking about vector algebra now. It's a representation of vectors. If you're speaking about matrix algebra, that's big, because now you're going into big stuff like group theory, basically. When you speak vector, you have to speak vector spaces. That's very high mathematics. Now, I'm sorry for complicating it. I'm just intrigued, just on the fact that these ancient guys had base, were thinking in terms of base 10, base 2, base 12, base 20. I mean, you might call it arithmetic. Don't deny that. But let's come down to the modern age where we speak computers, and we know that binary language is base 2, basically. It's one of the um, but binary language is a language of computers. simply put. Right. Now, basically, to speak about a base, when you say base 10, you are saying you've got 10 distinct uh, 10 distinct numbers, let's call them numbers for now, or representations of numbers, with which to represent all the numbers in the universe. Now, when you've got base 2, you've got only 2 of those guys, like 0 and 1 is used because it's extracted from the decimal system, which is 0 up to 9. Decimal means 10, basically. I don't know what decimal is. I thought decimal was a comma, but 10, whatever 10 is, from 0 up to 9.
Mm-hmm.
With 0 and 1, which is binary, 2, 0 and 1. So you find strings of, like, if you were to write 3 in binary, it will look weird to you. It will look like 11 because you are thinking base 10, you know. So people who have done hardware will, especially electronics or engineers, electrical engineers, will associate with the use of binary when it comes to a microchip. In other words, I'm asking myself, were these people close to even discovering a computer? Maybe I sound weird, but we know today that binary systems are instrumental in computing, right? If you can think in base 2, you've got only 2 digits or 2 unique objects with which to represent all the numbers in the universe. Now, that's what a computer does. That's the basis of representation of stuff in, if even colors. For instance, colors in use what is called an RGB, red, green, and RGB, red, green, and blue, to represent all the colors that you can see in your computer. RGB. Sometimes it's called RGBA, where the A is the alpha. Things of that nature. Because I would look at RGB as basically 3 digits, 0, 1, and 3, meaning base 3. Right. If people are able to think in terms of base something, that's advanced. That's advanced numerical system. You are not thinking arithmetic, you are thinking mathematics itself. But, I'm glad that I can see the historical perspective of mathematics. And I'm just concerned that if you skip the chronology, we might throw away important information that we can use to extract how we should be doing things today. Because we are presented with other things, and a lot of things our people or many people don't know because they're stored somewhere. I mean, what is a rind papyrus? Where is it? I thought it was a paper. Where is it? Why isn't it not readily available? Well, maybe through internet it is. I'm not complaining, but why am I not seeing it in textbooks?
Well, it's in mathematic textbooks, but it's not in my college. It wasn't in my college textbook. I guess certain ones. I'm not sure, man. And only thing I can know is inherently racism and bias that causes that not to be put in books if it's not in the majority of timely books today. We would see the historical perspective of mathematics, but I didn't see it, or maybe I got to relook into my textbook. I didn't see it. Like, for example, we find Arab media that suggests that Arabs are the father of algebra. Problematic. As we see here, the Islamic mathematics came after the Indian mathematics.
So
and like you said, if we're using mathematics for our logic and reasoning, having a mathematical mind, how much of mathematics we are missing from ancient Africa, or what they call proto-mathematics, all the way to algebra, which is thousands of years before even Nile Valley Black Africans begin to develop their civilization. And how much mathematics we are missing. We ain't getting the true essence of mathematics. So I agree with you 100%. That's good thinking. The Rhine papyrus can be seen anywhere. It can be in any peer review data. It can be seen in any library. The Rhine papyrus. I looked at a .edu. .edus are good. We have two .edus we looked at. We looked at the University of Buffalo, and then we looked at the University of North Carolina, Wilmington, and they both said the same exact thing, timely, 2023, about mathematics and algebra beginning in Africa. So you know, it's you're correct. It's problematic issues. Even with, I'm noticing mathematics now in divination systems. African divination systems should be studied mathematically. I'm not saying false the metaphysical stuff, but they do have mathematics inside of certain divination, African divination, or African spiritual systems of calculations, etc. So we throw out what we can't use, and we learn what we can use. So the Rhine papyrus can be found on any Egyptological library, on the internet, anywhere. I mean, fully translated at that. We just viewed the ones that was fully translated. So let me show you this to get your commentary on it. And this is the Rhine papyrus. All right. This University of Buffalo. And we're going to go directly to problem 72, which is here, simple algebra. All right.
Yeah.
I'll mute my mic, let you do commentary here.
So, now, if I can say something.
You can see it? You can't see?
Yeah. Can I make a comment on what you're showing, problem 72?
Oh, yeah, go ahead. Yep.
Yes.
Yeah.
Because the problem, as you read it, problem 72, is classified today in many textbooks, high school textbooks, primary textbooks, as what is called word problems, right? Where you find, even from myself, I had a problem with word problems, because word problems basically ask you to formulate a problem given in a natural language like English, whatever, mathematically, so that you can apply the rules of mathematics to solve that problem. Word problems are a problem themselves. Trust me, without even knowing the meanings of what a peso is, 100 laws of X, I don't know what peso 10 is. To formulate it algebraically is always a problem, right? But I'm asking myself, this is Rhine papyrus, which existed in year what?
Okay, let's see some dates here.
So these ancient guys could solve word problems, and we're having problems with word problems.
Right.
You understand what I'm saying? So
absolutely.
we shouldn't be having problems. We shouldn't be having problems with word problems. we're speaking words now, right? We're speaking words. Probably this is not suggesting that someone must write a mathematical algebraic expression for what we're talking about. No, right? But everyone can comprehend what we are saying. If I say, hey, Neb, how are you? Everybody can comprehend that. That's a natural language. Now, how can you not understand a word problem when the ancient, that's problem 72. Am I dreaming? What is the year? We shouldn't be having problems like these.
Okay. The year of the Rhine, I gave it,
Yes, you did.
let's see here.
You did. I just don't remember it. Yeah, but you did.
I'll go back to it. No problem, man.
The Moscow Papyrus is 8 BC, 1800, 1850 BC.
The Rhine mathematical papyrus is dated to, and I will show you
Three.
the actual. All right. Let's see the dates here. It's actually in the British Museum. British Museum number 10057. So we can actually see it in the British Museum. So let's take a look at this real quick. Okay, so it's museum number 157.
Mm-hmm.
Anybody who have the online can access it directly. And this how it looks. If this is, yeah, beautiful. And this is hieratic. I think, and you even see drawings of pyramids and slopes and all of that. So this is the mathematical papyri of Rhine, where we have that problem 72. That so let's see the date. 1550 B, according to, let's see the source. Oh, British Museum. According to the British Museum, is 1550 BC.
1550 BC.
Yeah, they are doing algebra in word problem algebra at that.
That's like 3,000 years ago, right? I have to add 2,000.
Correct.
That's a
Probably
very
about
long time.
3,500 years ago.
Yes. They could solve word problems that we have a problem with today. That doesn't make sense. Something is wrong. We shouldn't be having a problem with
And
word
another
problems.
significant point is where the Rhine papyrus was found. As a historian, let's look into where it was found. It's found near Nubia, sub-Saharan Africa. See that? It's found near Nubia. According to peer review data, mathematics descended from sub-Saharan Africa somewhere. I believe Southern Africa. That's just my historical evaluation because of the late Paleolithic migrations from that area of Southern Africa and Central Africa into the Nile Valley area historically. So they would have brung their mathematics with them, and this is why we have a connection, a relationship with Nile Valley mathematics, with South African mathematics, Central African mathematics, and East African mathematics. This is why. In Kemet, mathematically, numbers represented sticks and bone. In Southern Africa, the oldest mathematical instrument is a bone. And also, you had another bone that was found 22,000 years ago in Central Africa. Then we have counting sticks or tally sticks. Those representations are sub-Saharan African in origin. And we can see that in the development of Nile Valley African mathematics. Thebes is where Rhine's papyrus was found or excavated. It was found in Thebes. Thebes near Nubia, again, sub-Saharan Africa. These places are close, in close proximity, where diffusion is also happening amongst population groups as they migrate and remigrate, etc. Due to different causations like push or pull factors. So that's just another point I would like to iterate.
Great historical facts, man. Well, this I know will be is the basis of because I like to teach children mathematics. Give them a historical perspective, and I think you have done justice to it to boost their self-esteem. To say, well, your great-fathers did this, so you shouldn't be having a problem with it. Whether you have a problem with mathematics, so no one is justified in Africa to say he's got a problem with mathematics anymore. I'm claiming.
That's right.
So, but thanks for the history, to see the chronology of how it develops. Obviously, we're not throwing away anything. Whatever, how it evolved into other areas, Mesopotamia, up to the modern age,
right?
All that is important. Nothing should be thrown away.
Correct.
We need all the information.
Yes, we
and
do.
You have done justice to that. Great historical perspective. Thank you, Nell.
Dua, shop.
Dua, shop, Melty.
Welcome to Katika, the peer review science channel. Donate to our channel on PayPal, pernaturallinguistics@gmail.com.